Some objects falling from the sky are older than the Earth. This audiobook invites you to trace the oldest meteorites in the solar system, primitive fragments that were born before the planets survived titanic collisions and traveled for billions of years until landing in our hands. What secrets do these witnesses of origin hold? A journey through the oldest matter we have ever touched and through the first pages of our cosmic history. Meteorites are fragments that have survived the journey through the Earth's atmosphere, falling to our planet from the far reaches of space. But why are they so important? Imagine that meteorites are like messengers from ancient times, bearers of information that speak to us of an era when the solar system was in full formation. Each meteorite is a witness to history, and by studying them we can unveil secrets that have remained hidden for millions of years. When thinking of meteorites, it's easy to confuse them with meteors and meteoroids, but what is the difference between them? Meteoroids are the small fragments floating in space, while meteors are those bright flashes we see when a meteoroid enters the atmosphere and burns up. And when those fragments manage to land on Earth, they become meteorites. Thus, each term describes a different stage in the journey of these cosmic objects. Now, the history of the solar system is an epic narrative that began billions of years ago. In this vast cosmic stage, meteorites played a crucial role. They were the building blocks that helped construct the planets, including Earth. Without them, our history would be completely different. Can you imagine a world without these ancient builders? The formation of our planet is intertwined with that of those celestial bodies that traveled through space. To understand how meteorites form, it is helpful to think of them as the remnants of a great cosmic kitchen. When asteroids collide or fragment, they generate these small pieces that can travel through space for millions of years. Thus, meteorites are like the leftovers from an interplanetary feast, each with its own story and unique characteristics. This formation is not an isolated event, it is a continuous process that shows us the dynamics and evolution of the solar system. But what do meteorites tell us about the age of the Earth? Imagine that each meteorite is like a time capsule. By studying them, scientists can obtain clues about when and how they formed, which in turn allows them to estimate the age of our planet. This connection is vital for understanding our place in the universe and the time that has passed since Earth began its journey around the Sun. Some meteorites are particularly ancient, and their study has revealed valuable information. For example, some of the oldest known meteorites are over 4 billion years old. These meteorites are not only fascinating because of their age, but they also offer us a window into the events that took place in the early days of our solar system. Can you imagine holding in your hands a fragment of the history of the universe? The isotopes present in meteorites are like the fingerprints of their origin. Through them, scientists can trace where they come from and how they relate to other celestial bodies. This information is crucial as it helps us understand not only the history of meteorites but also that of our own planet and its neighbors in the solar system. Isotopes are undoubtedly a powerful tool in space research. Water is another intriguing aspect related to meteorites. Did you know that some meteorites contain water in the form of ice or in chemical compounds? This has led scientists to investigate whether meteorites could have brought water to Earth, an essential element for life. The search for water in space has changed our understanding of how our planet formed and the possibility of other habitable worlds existing. The giant impact theory is one of the most striking stories involving meteorites. It is suggested that a large meteorite impacted the Earth, leading to the formation of the Moon. This monumental event not only shaped our natural satellite but also had profound implications for life on Earth. What if that impact had not occurred? The history of our planet could be radically different. The connection between meteorites and life on Earth is another fascinating topic. Some scientists have proposed that meteorites may have brought the necessary ingredients for life to emerge on our planet. Thus, these celestial bodies are not only messengers of the past, but also potential bearers of life itself. Could it be that life on Earth has an extraterrestrial origin? Throughout human history, meteorites have captured people's imagination. From ancient civilizations that considered them divine messengers to modern scientists studying them to unravel the secrets of the universe, meteorites have left an indelible mark on our culture and knowledge. What impact have they had on the way we understand our place in the cosmos? The search for meteorites is an exciting adventure that involves advanced techniques and methods. Scientists use sophisticated tools to locate and study these objects, allowing them to discover more about their composition and origin. The exploration of other planets and asteroids has opened new opportunities to find meteorites and better understand the processes that have shaped our solar system. By exploring other planets such as Mars, scientists have found evidence of meteorites that have reached their surfaces. These studies not only help us learn more about Mars, but also expand our understanding of how meteorites have influenced other celestial bodies in the solar system. What secrets do meteorites from other planets still hide from us? Space mining is a concept that has begun to take shape in recent decades. With the potential to extract resources from meteorites, scientists and entrepreneurs are exploring how these celestial bodies could be the key to future space missions. This idea raises intriguing questions about the sustainability of space exploration and our ability to use these resources for the benefit of humanity. Meteorite impacts on Earth have had significant historical consequences. From events that have altered entire ecosystems to those that have influenced the development of civilizations, meteorites have left their mark on the history of our planet. What lessons can we learn from these events to protect our future? Planetary defense is an emerging field that seeks to identify and mitigate the risk of meteorite impacts on Earth. Scientists are working hard to develop strategies that allow us to anticipate these events and protect our planet. It is a monumental task that requires collaboration and advanced technology. Finally, the future of meteorite research is promising, with new space missions on the horizon and advances in technology. We are on the brink of discovering more about these fascinating celestial bodies. Each new finding has the potential to change our understanding of the origin of the solar system and our own existence. What revelations await us on the horizon? Meteorites are fascinating objects that orbit in our solar system, and when they manage to pass through the Earth's atmosphere and land on our planet, they tell us stories from distant times. But what exactly are meteorites? To understand this, it is first important to know some related terms. Meteors are those bright flashes we see in the night sky, often called shooting stars. However, they are actually fragments of material that burn up upon entering the atmosphere, creating that beautiful trail of light. On the other hand, meteoroids are much smaller and can be considered the younger siblings of meteorites. These are pieces of rock or metal that float in space, and if they manage to survive their passage through the atmosphere and land on Earth, they become meteorites. So what is the difference between a meteor, a meteoroid, and a meteorite? It's simple. Meteoroids are the small pieces of matter in space. Meteors are what we see when those pieces enter the atmosphere and shine brightly, and meteorites are those that reach the Earth's surface. Imagine a journey on a train. The meteoroid is the passenger at the station. The meteor is the same passenger traveling through the tunnel, and when he finally gets off at his destination, he becomes a meteorite. Each has its own moment and place in this cosmic journey. Meteorites are classified into three main groups. First, we have rocky meteorites, which are primarily composed of minerals. Then there are metallic meteorites, which contain a high proportion of metals like iron and nickel. Lastly, we find mixed meteorites, which combine both rocks and metals in their composition. Each of these types offers a unique window into the past of our solar system. But why are meteorites so important? Imagine you are trying to piece together a puzzle of the history of the universe. Each meteorite we find is like a piece of that puzzle, helping us understand how planets and other celestial bodies formed. Meteorites act as time capsules, preserving information about the solar system in their chemical and physical structures. Moreover, by studying meteorites, scientists can determine the age of different celestial bodies. Through their analysis, clues can be uncovered about when they formed, which helps us better understand the timeline of the universe. This is especially relevant when we consider that some meteorites may be older than the Earth itself. Some meteorites have traveled through space for billions of years, and each one has a story to tell. For example, the Allende meteorite, which fell in Mexico in 1976, is one of the most studied and has provided valuable information about the formation of the solar system. These rock fragments allow us to learn more about the processes that led to our home in the cosmos. But how do these meteorites become part of our history? Most come from asteroids that orbit between Mars and Jupiter. When these asteroids collide with each other, they break into pieces, and some of these fragments can be deflected by gravity towards Earth. It's like having a bag of marbles, and as you move, some fall to the ground. Each marble is a meteoroid, and if one of them reaches your home, it becomes a meteorite. The exploration of meteorites also leads us to another interesting concept: isotopes. These are versions of chemical elements that have the same number of protons but a different number of neutrons. By studying the isotopes in meteorites, scientists can understand their origin and the history of our solar system. It's as if each meteorite has a cosmic passport that reveals where it came from and when it arrived on our planet. The search for meteorites is not limited to Earth. On Mars, for example, scientists have found evidence of meteorites and studied their characteristics. These findings not only inform us about Mars, but also help us better understand the shared history of our solar system. Thus, each meteorite found can open new doors to surprising discoveries. The relationship between meteorites and water is also fascinating. It has been discovered that some meteorites contain ice and other compounds that could have contributed to the formation of water on Earth. This raises intriguing questions about the origin of water on our planet and its role in the development of life. Could these meteorites have been the messengers of water? Finally, when reflecting on meteorites, it is important to consider their place in our history and culture. Throughout the centuries, meteorites have captured the imagination of humanity, inspiring myths, legends, and scientific advancements. From ancient civilizations that revered them as messengers of the gods to modern scientists who analyze them in laboratories, meteorites have left an indelible mark on our understanding of the cosmos. So the next time you see a shooting star cross the sky, remember that it could be a meteor on its journey, and that behind it is a story larger than life itself, told through the meteorites that have reached our planet. What secrets do these space travelers hold? The answer lies in every fragment that falls from the sky, waiting to be discovered and understood. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. How did our solar system form? What role did meteorites play in this fascinating process? To understand the history of the solar system, it's essential to travel back in time to an era when everything was in chaos. Imagine a vast space filled with dust and gas, where collisions and explosions were a daily occurrence. In this scenario, meteorites acted like small artists that, through their influence, would shape our cosmic home. Meteorites, those fragments of rock and metal that fall to Earth, are actually pieces of a very ancient past. During the formation of the solar system, which began about 4.6 billion years ago, meteorites played a crucial role. They were everywhere, forming part of a large mosaic of matter in which planets, moons, and asteroids were being born. But how can these small bodies have such a significant impact on the creation of worlds? The story begins with a cloud of gas and dust that, for reasons still debated, started to collapse. As this cloud compacted, a rotating disk formed. In the center, the sun began to take shape, while the remaining materials started to come together. This is where meteorites come into play. Through a process known as accretion, small particles of matter stuck together, forming increasingly larger bodies. Can you imagine what that environment was like? A place where collisions between these small building blocks were common, creating new celestial bodies. Meteorites were not only part of the matter that formed the planets, but they were also witnesses to the history of the solar system. By studying these fragments, scientists can reconstruct the timeline of events that led to the creation of Earth and other planets. For example, some meteorites contain elements that formed in the early stages of the solar system, providing us with clues about the conditions that existed at that time. Thus, meteorites act as time capsules, transporting us to an era when everything was in formation. The history of the solar system can be compared to a large puzzle. Each meteorite is a piece that, when placed in its correct position, reveals a different aspect of this complex story. But what happens when a meteorite encounters a planet? The answer is fascinating. When a meteorite collides with a planet, it not only leaves a mark on its surface, but can also contribute to the planet's chemical composition. This is especially true in the case of Earth, where some meteorites have brought with them the ingredients that allowed life to emerge. However, not all meteorites are the same. There are different types, and their composition can vary significantly. Some are primarily made of metal, while others are rocky. This diversity helps us understand the different processes that occurred in the solar system. In this sense, meteorites are like puzzle pieces that, when analyzed, reveal not only the story of their own formation, but also that of other celestial bodies. Let's talk a bit more about the context in which these meteorites originated. While the planets were forming, some bodies failed to become planets and remained as asteroids. These asteroids, being smaller, are more likely to collide with each other, often resulting in the creation of meteorites. Thus, meteorites can be considered the survivors of a process in which many other celestial bodies did not fully form. Over millions of years, some of these meteorites have reached Earth, leading us to wonder, what secrets do they hold? Every time a meteorite falls, it gives us the opportunity to learn more about the history of the solar system. By analyzing its composition, scientists can determine where it came from and how it formed, helping us better understand not only our origin but also that of other planets. Meteorites also tell us something about water in the solar system. It has been discovered that some meteorites contain water compounds, suggesting that water may have arrived on Earth through these celestial bodies. This raises intriguing questions about how life formed on our planet. If meteorites brought water and other essential compounds, could it be that they also brought the seeds of life itself? The history of the solar system is ultimately a story of interconnectedness. Every meteorite, every collision, and every cosmic event has contributed to what we are today. Just as meteorites have influenced the formation of Earth, they have also left their mark on the history of humanity. Since ancient times, meteorites have fascinated people, inspiring myths and legends in various cultures. The search for meteorites is not just a scientific curiosity, it is a way to discover more about ourselves and our place in the universe. By studying these fragments of space, we not only unravel the mysteries of the solar system, but also connect with the history of our planet. Meteorites are, without a doubt, a window into our past and a guide to understanding our future. Meteorites are fragments of rock and metal that have managed to traverse the Earth's atmosphere and land on our planet. But have you ever wondered how these small cosmic travelers reach us? To answer this question, it is important to understand that meteorites do not appear out of nowhere. They are the result of fascinating and complex cosmic processes. The story of a meteorite begins in the vastness of space, where there are many floating rocks. Some of these rocks come from asteroids, which are larger bodies that orbit the Sun, primarily in what we know as the asteroid belt, between Mars and Jupiter. Imagine a large zone of space debris where each fragment has its own story. But what happens when one of these fragments becomes a meteorite? When an asteroid suffers a collision, it can break into pieces, and those pieces can start wandering through space. Some of them, on their journey, head towards Earth. Most of these fragments disintegrate due to heat and friction upon entering the atmosphere, becoming meteors that briefly shine in the sky. This phenomenon is what we commonly call a shooting star. However, some of these fragments are large enough to survive this trial and, upon reaching the Earth's surface, become meteorites. An intriguing question then arises: what is the difference between a meteor and a meteorite? The answer lies in the moment they are encountered. While a meteor is the bright light we see in the sky, a meteorite is the fragment that ultimately reaches Earth. This process is like a bowling ball knocking down a pin. The ball is what is seen in motion, but the pin is the final destination of the impact. Once a meteorite lands, its journey is not over. In fact, it is just the beginning of a new adventure. Scientists are eager to study these objects, as they can offer a window into the past of the solar system. But how is a meteorite actually formed? To understand this, it is helpful to think about the formation of planets. During the creation of the solar system, billions of years ago, a cloud of gas and dust began to collapse and spin, forming the sun and the planets. In this process, meteorites were formed as byproducts of the material that did not come together to form planets. Each meteorite has a unique story, and its composition can vary greatly. Some are made primarily of metal, such as iron, while others contain rocks and minerals. This diversity leads us to another question. What can they teach us about the origin of the solar system? Meteorites are like time capsules that tell us about the materials and conditions that existed in space billions of years ago. By studying them, scientists can reconstruct the history of our own planet and its neighbors. The formation of meteorites does not occur randomly. There are specific processes that determine their composition. For example, some meteorites come from the crust of asteroids, while others may be fragments of comets. This variety in their origin is fundamental to understanding the different types of meteorites that exist. In simple terms, a meteorite can be considered a visitor from the past that brings us stories from distant places. The conditions under which meteorites form are also extraordinary. Sometimes these fragments can experience extreme temperatures and pressures during their formation. This makes them true treasures of space, as they contain valuable information about the chemistry and physics of the celestial bodies from which they come. However, what happens after a meteorite impacts the Earth? Once on our planet, meteorites can be the subject of intensive study. Scientists use advanced techniques to analyze their composition and determine their origin. This includes the use of mass spectrometry, which allows them to identify the elements present in the meteorite. But why is it so important to know their composition? Each discovery can provide clues about the formation of other celestial bodies and therefore about the history of our own solar system. Moreover, meteorites are essential for understanding the evolution of Earth. By analyzing these objects, scientists can learn about the conditions that existed in the early days of our planet. Who would have thought that a small fragment of rock could reveal so much about our history? It's as if each meteorite carries an ancient secret waiting to be uncovered. The fascination with the formation of meteorites doesn't end there. As scientists continue to investigate, each new finding can open the door to new questions. Could some meteorites contain the necessary ingredients for the development of life? The answer to this question is not only intriguing but could also change our understanding of how and where life might exist in the universe. In summary, the formation of meteorites is an amazing process that connects us to the vast cosmos. These fragments of rock and metal are much more than simple objects. They are carriers of crucial information about the past of our solar system. Every meteorite that falls to Earth is an opportunity to learn, explore, and reflect on our place in the universe. So the next time you see a shooting star in the sky, remember that behind that flash is a story that has traveled through the vastness of space just to reach you. What do meteorites tell us about the age of our planet? This question is fascinating and leads us to explore a world where the history of Earth and the solar system intertwine in surprising ways. Often, we think of Earth as a fixed and stable place, but in reality, it is in constant change and evolution. Meteorites, those travelers from space, can be the pieces of the puzzle that help us understand not only how our planet formed, but also how much time has passed since then. When we think of meteorites, it's easy to imagine rocks falling from the sky, but did you know that some of them are like time capsules containing valuable information about the past? Through their study, scientists have discovered that many meteorites are older than Earth itself. This means that by analyzing them, we can peek into the dawn of the solar system and understand how and when the planets emerged. To put it into perspective, consider this. If the history of Earth were a book, meteorites would be the first pages, describing a time before continents and oceans existed. By studying meteorites, scientists can determine their age using techniques like radiometric dating, a method that measures the decay of certain isotopes present in the rocks. This gives us a window into the past, revealing that some meteorites are over 4,600,000,000 years old. But why is it so important to know the age of meteorites? The answer lies in the connection between these celestial bodies and the formation of the solar system. Meteorites are remnants of the material that did not become planets. They are like the leftovers from the banquet of creation. And their study helps us understand how Earth and its neighbors formed. By knowing the age of meteorites, we can estimate when various celestial bodies formed and how matter was distributed in space. Let's imagine that meteorites are like footprints in the sand of a beach. Each footprint tells a story about the past, and by putting them together, we can reconstruct the journey of the bodies that have passed through. In this way, meteorites act as silent witnesses to a time when the sun, planets, and other celestial bodies were in the midst of formation. By analyzing their characteristics and composition, scientists can infer the environment in which they formed and how they relate to the history of our planet. In this sense, meteorites also provide us with clues about the geological history of Earth. For example, some meteorites contain isotopes of elements like oxygen and carbon, which formed under specific conditions in space. By comparing these isotopes with those found on Earth, we can gain information about how and when our oceans and atmosphere formed, as well as the origin of the elements that make up our life. On this journey through time, meteorites also help us answer intriguing questions about the evolution of life on our planet. By studying the conditions in which they formed, scientists can speculate about how those same elements might have influenced the emergence of life. It's as if meteorites carry a kind of cosmic DNA that narrates the story of how the necessary ingredients for life arrived on Earth. And what about the meteorites that have impacted our planet? These events have left marks on the history of Earth, and some of them coincide with key moments in the evolution of life. For example, it is believed that a massive impact around 65 million years ago was responsible for the extinction of the dinosaurs. By analyzing the remnants of meteorites that have reached Earth, scientists can better understand how these impacts have influenced the development of life over the eons. It's astonishing to think that by looking up at the sky and observing a meteorite, we are looking back in time to a period when the solar system was forming. Every meteorite that falls to Earth is an opportunity to learn more about our own history. The study of these celestial bodies continues to reveal secrets about the age of our planet and its evolution, and each discovery brings us a little closer to understanding our place in the universe. The relationship between meteorites and the age of Earth is a field still full of mysteries. As technology advances and new analytical techniques are developed, we are likely to obtain answers to questions we have yet to ask. Meteorites are not only witnesses to our past, but may also be the key to unlocking the secrets of our future. In summary, meteorites are like the pages of an ancient book filled with stories yet to be told. They speak to us of the formation of our solar system, the history of Earth, and the events that have shaped our planet. By studying these fascinating celestial bodies, we not only learn about the past but also prepare for the future, gaining a better understanding of how we interact with the cosmos that surrounds us. So the next time you see a meteorite, remember that you are looking at a fragment of the history of our universe, a story that is still being written. In the vast universe, there are fragments of history that have traveled through space for billions of years. Some of them, the oldest meteorites we know, are true treasures of the cosmos. But what makes them so special? The answer lies in their ability to tell us about the beginnings of the solar system, and therefore about the very history of Earth. First, let's talk about a meteorite that captures the attention of scientists and curious minds alike. the Allende meteorite, which fell in Mexico in 1976. This meteorite is famous not only for its spectacular fall, but also because it contains some of the oldest materials that have been found in our solar system. Isn't it amazing to think that these fragments have been in space since before Earth existed? Now, what characteristics make a meteorite considered ancient? Generally, its chemical composition and structure are evaluated. The oldest meteorites often contain isotopes of elements that formed in the early stages of the solar system's life. This makes them time capsules that have preserved information about the moment when the planets formed. A notable example is the Murchison meteorite, which fell in Australia in 1969. This meteorite has provided clues about the formation of organic compounds in space. Imagine what that means. The basic ingredients of life could have formed in space before arriving on Earth. Who would think that a simple piece of rock could contain secrets about the origin of life? Meteorites are also classified according to their composition. Some are made of iron, others of rock, and the most intriguing are those that contain a mixture of both. This diversity tells us a lot about their origins. For example, chondrite meteorites are considered some of the most primitive and help us understand the conditions of primitive space. Some of these meteorites may contain small spheres of minerals called time capsules. These spheres are witnesses to the conditions under which they formed, providing us with information about the temperature and pressure of space at that time. Can you imagine being able to look inside a sphere and see what the universe was like billions of years ago? Another fascinating aspect of ancient meteorites is their relationship with other celestial bodies. Many of them come from the asteroid belt between Mars and Jupiter. By studying these meteorites, scientists can reconstruct the history of the asteroids that originated them, the collisions that occurred, and how those events have shaped our solar system. It's like a cosmic puzzle where each meteorite is a piece that helps us understand the complete picture. Moreover, the research of ancient meteorites has revolutionized our understanding of chemistry in space. By studying the compounds found in these meteorites, scientists have discovered that some of the same elements that form life on Earth are present in space. This raises an intriguing question: are meteorites, in a sense, messengers of life that once existed elsewhere in the universe? Some meteorites also contain minerals that are extremely rare on Earth, which adds even more value to them. These minerals can offer clues about the extreme conditions that existed in space. So when we look at an ancient meteorite, we are not just observing a piece of rock, we are holding a fragment of the past. One of the great surprises of ancient meteorites is their role in planet formation. It is believed that these celestial bodies played a crucial role in the accretion process, where small particles came together to form larger bodies. In this sense, meteorites are part of the story of Earth's creation. Isn't it incredible to think that every time a meteorite enters our atmosphere, it brings with it the history of the universe? Studies of meteorites have also revealed that some of them contain water, which opens new doors regarding the possibility of bodies of water existing on other planets. Although it sounds incredible, these rock fragments have been fundamental to our understanding of how water could be present elsewhere in the solar system, and not just on Earth. In summary, the oldest meteorites are more than just simple rocks from space. They are time capsules that offer us a window into the origin of the solar system and the history of our own planet. Each meteorite has a story to tell, and by studying them, we are unraveling the secrets of the universe. So the next time you see a meteorite, remember that you are in the presence of a witness to cosmic history. It is a reminder that, although Earth is our home, we are part of a much larger story, a story that began billions of years ago and continues to unfold today. Ancient meteorites are a tangible connection to our past, and their study helps us understand not only where we come from, but also where we might be going. Meteorites are like time capsules that tell us stories about the universe, but what secrets do these fragments of rock that cross space and sometimes reach Earth reveal? One of the most fascinating aspects of meteorites is the information they contain about isotopes. These isotopes are versions of chemical elements that have the same number of protons but different numbers of neutrons. This may sound complicated, but imagine that isotopes are like different flavors of the same ice cream. Although they are all ice cream, each flavor has its own particular characteristic. When scientists analyze the isotopes in meteorites, they can uncover details about their origin. For example, if a meteorite has a high content of a particular isotope of oxygen, it may indicate that it comes from a specific place in the solar system. It's as if you had the ability to trace the path a traveler has taken just from their footprint. Thus, isotopes provide us with clues about the history of these celestial objects. But why are isotopes in meteorites so important? Delving a little deeper, we find that these elements help us understand the conditions under which they formed. Just like analyzing an old photo, we can infer the environment, the era, and the events that led to the creation of that image. In the case of meteorites, isotopes are like the marks of time that allow us to reconstruct the past of the solar system. Let's talk about one particular isotope: carbon. This element is not only fundamental for life on Earth, but is also present in many meteorites. By studying the proportions of its isotopes, scientists can learn about the chemistry that existed in space billions of years ago. It's like investigating the ingredients of a secret recipe that has been kept for generations. Each isotope can offer a small clue about the history of matter in the universe. Now, what about hydrogen isotopes? These also play a crucial role. There are different forms of hydrogen, and their analysis in meteorites can help unravel the history of water in our solar system. Did you know that some meteorites contain water in their composition? This suggests that water may have been present elsewhere before arriving on Earth. Thus, hydrogen isotopes provide us with a window into the origins of water on our planet, a vital resource for life. Moreover, isotopes of elements like nickel and iron also provide valuable information. These metals are common in meteorites and can tell stories about the conditions in space where they formed. Each isotope of these elements has its own unique story, like a chapter in a book that narrates the evolution of our solar system. Now, what happens when we compare the isotopes of meteorites with those of Earth? It's somewhat like comparing two friends who have grown up together but have taken different paths. This comparison can reveal whether the materials that formed our planet came from the same place as the meteorites. Through this examination, scientists can better understand how Earth and its neighboring planets were assembled. However, not everything is straightforward. Sometimes isotopes can provide contradictory information. Imagine reading a book where some pages say one thing and others seem to contradict it. In the world of meteorites, this can lead to debates and new theories about how our solar system formed. It serves as a reminder that science is a constantly evolving field, full of questions that are still seeking answers. Isotopes also play a role in dating meteorites. Through specific techniques, scientists can determine the age of a meteorite by analyzing the proportion of certain isotopes. It's like counting the wrinkles on an elderly person's face to estimate their age. In this way, we can appreciate how much time has passed since those celestial bodies formed. Finally, studies on isotopes in meteorites are not only interesting from a scientific standpoint, they also have implications for the future. Understanding the isotopic composition of meteorites may influence how we approach space exploration and the search for resources on other planets. Perhaps one day, thanks to these small fragments of the cosmos, we will discover how to utilize asteroid resources for life on Earth or in lunar colonies. In summary, isotopes in meteorites are like the fingerprints of the universe. Each one tells a unique story that helps us better understand the past, present, and perhaps even the future of our planet and beyond. By studying these elements, we are not just looking at the sky, we are exploring our place in the vast cosmos. It is a fascinating journey that is just beginning, and meteorites are our guides in this intergalactic adventure. Have you ever looked up at the starry sky and wondered where the water that covers most of our planet comes from? The relationship between meteorites and water in the solar system is a fascinating topic that helps us understand not only the origin of our own world, but also that of other celestial bodies. Within this narrative, meteorites play a crucial role, acting as messengers from space, bringing clues about the history of water and its distribution in the universe. Meteorites, those fragments of rock and metal that have traveled through space for millions of years, can contain water in unexpected forms. But how is it possible for a rock from space to contain something as essential as water? The answer lies in their chemical composition. Many meteorites, especially those from asteroids, are made up of minerals that can retain water molecules. These meteorites, known as carbonaceous meteorites, are like little time capsules that tell us stories about the conditions that existed in the early solar system. Imagine the solar system as a large kitchen where all the ingredients are prepared to make a delicious dish called Earth. In this kitchen, meteorites act as the chefs, bringing the necessary ingredients. Some of these ingredients are compounds that, when combined, form water. Throughout history, scientists have discovered that these meteorites absorbed water under very cold conditions when they formed in space, suggesting that water may have been present in the solar system since its beginnings. But what about the water on Earth? Could it have arrived here through meteorites? This is one of the most intriguing questions in astrobiology. Many researchers believe that during the early stages of Earth, when our planet was still forming, a constant rain of meteorites could have brought significant amounts of water. This process, resembling a celestial shower, may have been fundamental in filling oceans and rivers, turning Earth into the home we know today. Recent studies have revealed that there is a specific type of meteorite called CI-type meteorites that has a composition very similar to that of the water found in Earth's oceans. This has led scientists to speculate that these meteorites could have been one of the main sources of water on our planet. Imagine that instead of simple rain, what really fell from the sky were pieces of a puzzle that, when fitted together, formed the oceans we know today. However, the story of water is not limited to Earth. Other celestial bodies, such as Mars and the moons of Jupiter and Saturn, have also shown signs of water. Through studies of meteorites, scientists have found that some of these bodies may have had suitable conditions to harbor water in the past. This raises an even more fascinating question. Could there be life elsewhere in the solar system? If water is an essential ingredient for life, then the existence of water on other planets increases the chances that life could also exist there. Exploring the relationship between meteorites and water also leads us to reflect on the future. If one day humans decide to colonize other planets, understanding how meteorites have brought water to Earth could be key to finding resources on other worlds. We could learn to use meteorites to supply our space colonies like a kind of intergalactic supply. It is interesting to consider how, in a vast universe, meteorites could be our connection to other worlds. Every time a meteorite impacts Earth, it is as if a fragment from another place is telling us its story. By studying these bodies, scientists are trying to decipher not only the origin of water, but also the origin of life itself. Moreover, it has been discovered that some meteorites contain organic compounds, which are the building blocks of life. This has led to theories suggesting that meteorites may have seeded life on Earth, bringing the necessary ingredients from beyond our planet. The idea that life may have arrived on Earth through these messengers from space is a revolutionary concept that continues to generate debate among scientists. The search for meteorites has also led to unexpected discoveries. In some cases, researchers have found ice in meteorites that have fallen to Earth, confirming that water can exist in very diverse forms in space. This ice, in turn, could provide clues about how water formed in the solar system and how it has been distributed over time. As technology advances, new techniques are being developed to study meteorites and their water content. Scientists use spectroscopy and other advanced tools to analyze the chemical composition of these celestial bodies, allowing them to gain valuable information about their origin and their relationship with water. Each new discovery is another piece in the puzzle that helps us understand our history and that of the universe. The connection between meteorites and water is a reminder that the cosmos is full of surprises. Every time we look up at the sky and see a shooting star, we are witnessing a fragment of history that has traveled through time and space. The next time you see a meteorite streaking across the sky, remember that it could be carrying water and perhaps even life itself. In such a vast and mysterious universe, meteorites are an open door to exploration and discovery, a reminder that there is still much to learn about the origin of our planet and the place we occupy in the cosmos. The giant impact theory is one of the most exciting and complex stories about the formation of our planet and its satellite, the Moon. But what does this theory really mean? Essentially, it proposes that a gigantic celestial body, the size of Mars, collided with the Earth in its early days. This cataclysmic event not only changed the way we see our planet, but was also fundamental to the creation of the Moon. Can you imagine the impact of something so large crashing into the Earth? The energy released would be equivalent to millions of atomic bombs. This scenario, although it sounds like something out of a science fiction movie, has solid foundations in scientific evidence. Through studies of meteorites and analyses of lunar rocks brought back by the Apollo missions, scientists have found surprisingly close similarities between the composition of the Earth and that of the Moon. This suggests that both bodies share a common origin, but why is it so important to understand this event? The collision was not only a key moment in Earth's history, but also played a crucial role in forming the conditions that allowed life as we know it. After that great impact, the Earth was covered by an ocean of magma, which took a considerable amount of time for things to stabilize. And this is where meteorites come in. These small travelers from space have been, for millions of years, witnesses to the history of the solar system. By studying meteorites, scientists can reconstruct the puzzle of what the Earth was like before and after that great impact. Let's talk about the sequence of events. After the collision, the resulting debris began to orbit the Earth, forming a disk of material that eventually coalesced to form the Moon. Have you ever stopped to think about how much history is contained in the Moon? Each crater on its surface is a testament to the violence of space. But that's not all. This collision also affected the rotation of the Earth, and thus day and night began to have the duration we know today. However, the story doesn't end here. Meteorites, being the remnants of celestial bodies that have survived through time, also tell us about the conditions of space during that period. Some meteorites have been dated and offer clues about the time of the formation of the Earth and the Moon. For example, by studying a specific type of meteorite, scientists can estimate that the collision occurred about 4.5 billion years ago. This gives us a window into an almost unimaginable time. It's fascinating to think that those fragments falling to Earth, often invisible to the naked eye, are actually messengers from the past. And who are those messengers? Some of them are considered remnants of the planet era because they come from the same time when the planets formed. Imagine holding a piece of the history of our solar system in your hands. Meteorites also provide information about the primitive chemistry of the solar system. Some contain water and organic compounds, which is intriguing. Could these meteorites have brought the necessary ingredients for life to Earth? This is one of the most exciting questions scientists are trying to answer. The relationship between meteorites and water on Earth is an active field of study that could rewrite our understanding of how life began. Moreover, the giant impact theory leads us to reflect on the vulnerability of our planet. If an impact of that magnitude could shape the Earth and the Moon, what would happen if a similar event occurred today? Scientists are constantly scanning the sky for asteroids and comets that could pose a threat. Planetary defense has become a crucial field today, where humanity must prepare to protect its home. The story of the giant impact is undoubtedly a reminder that the universe is a dynamic and ever-changing place. Every meteorite that reaches Earth is a window to the past, a story waiting to be told. The next time you see a meteorite, think about all it has experienced and the role it has played in the history of our planet. Researching these celestial bodies not only helps us understand our past, but also prepares us for the future. Understanding the giant impact theory allows us to better appreciate the complexity of life on Earth. Every time we look at the starry sky, let us remember that those twinkling lights are more than just stars. They are fragments of a cosmic story that continues to unfold. So the next time you hear about meteorites, remember that they are more than just rocks from space. They are the remnants of an event that shaped our world and in some way connect us all in this vast and mysterious dance of the universe. In a corner of the vast universe, there lies a question that has intrigued scientists and curious minds alike. Could a meteorite be the key that opened the door to life on Earth? This idea, which at first glance sounds like a science fiction script, has roots in current scientific research. So let us travel together through this fascinating hypothesis. Meteorites, those small pieces of rock and metal that traverse space, may have been the messengers of essential ingredients for life. How is this possible? To understand this, we must first think about the basic components that make up life as we know it: carbon, hydrogen, oxygen, and nitrogen. Surprisingly, many meteorites contain these elements in abundance. Did these ancient cosmic travelers bring with them the fundamental building blocks to construct living organisms? Let's analyze this a bit further. Scientists have discovered that certain types of meteorites, such as carbonaceous chondrites, are not only rich in the elements we mentioned, but also contain amino acids, which are the molecules that form proteins. Proteins are vital for life, acting as structures, catalysts, and information carriers. So if these meteorites were able to deliver amino acids to our planet, could it be that life in its early stages was the result of a kind of cosmic delivery? Imagine the scenario on primitive Earth, an inhospitable world filled with volcanic activity. Amidst this chaos, some meteorites may have fallen, bringing with them the necessary ingredients. It would be like receiving a supply box in the middle of a storm. But nature is not just a gift, it is also a place of competition and adaptation. What happened after these meteorites impacted? How did those compounds transform into life? The theory suggests that the organic compounds brought by meteorites, when mixed with the right conditions on Earth, could have triggered complex chemical reactions. These reactions in turn would have allowed for the formation of more complex structures such as cells. It is a slow process, almost like a puzzle being assembled piece by piece. But what role did meteorites play in this puzzle? The history of life on Earth is a tale of survival and adaptation. And if meteorites were responsible for providing essential materials, then can we consider them the parents of life on our planet? This idea raises a fascinating question. If meteorites could bring life here, could the same happen on other planets in the vast universe? Where thousands of exoplanets have been discovered, the possibility that other worlds have received packages of life is an idea that sparks our imagination. Scientists have conducted experiments in laboratories simulating conditions similar to those of primitive Earth. By combining organic compounds and exposing them to energy, such as ultraviolet rays or electric discharges, they have managed to create amino acids and other basic life compounds. This suggests that while meteorites may have played a crucial role, life could also be a phenomenon that arises naturally under the right conditions. Some researchers have even considered that certain meteorites may have harbored microbial organisms within them. The idea that life can travel from one planet to another through meteorites is known as panspermia. It is an astonishing concept that explores the possibility that life is not exclusive to Earth but is an interplanetary phenomenon. However, not everything is that simple. The life we know is incredibly complex. And while meteorites may have been the carriers of the ingredients, a suitable environment is also necessary for these ingredients to become life. The extreme conditions of primitive Earth, such as its atmosphere and temperature, played a fundamental role in this process. So while meteorites may have done their part, can we claim that they are the sole responsible ones for life? This mystery about the connection between meteorites and the origin of life remains a subject of research. Each discovery brings us closer to understanding how it all began, but many questions remain unanswered. For instance, How do we know that the meteorites that have reached Earth are indeed the ones that contain the ingredients for life? The answer may lie in studying the meteorites that have impacted other celestial bodies, such as Mars, which could be remnants of a similar story. The fascination with meteorites and their possible connection to life goes beyond science. It invites us to reflect on our place in the universe. If meteorites are in some way responsible for life on Earth, then we all share a cosmic bond. The next time you look at the starry sky, remember that those bright points may be related to the story of your own existence. On this journey through the cosmos, we have explored the possibility that meteorites may have played a fundamental role in the creation of life on Earth. Science still has much to discover, but what is undeniable is that our universe is a place full of surprises. So let us continue searching and questioning, for each answer leads us to new questions and a greater understanding of our place in this vast and mysterious universe. Meteorites have been present in human history since time immemorial, but did you know that they have influenced our culture, science, and even the way we see the universe? Since ancient times, these celestial objects have fascinated people, awakening myths and legends. How is it possible that a simple piece of rock from space has left such a deep mark on human history? The connection between meteorites and humanity is as old as civilization itself. In many ancient cultures, meteorites were considered messages from the gods or even sacred components. In Egypt, for example, it was believed that a stone fallen from the sky was a divine gift. These beliefs were not just superstitions. Meteorites were often used in the making of tools and decorative objects, thus showing their material and symbolic value. Throughout history, meteorites have been silent witnesses to crucial events. In the Middle Ages, some people believed that meteorites were omens of disasters. Whenever a celestial object fell from the sky, ceremonies were organized to appease the gods. In this sense, meteorites were not just rocks, but symbols of the connection between the earthly and the divine. Science has also been impacted by these celestial bodies. The arrival of the scientific revolution brought a new approach to meteorites. Did you know that some of the earliest studies on meteorites helped establish the theory that the Earth was not the center of the universe? Scientists began to question existing knowledge and investigate the nature of these objects. As they acquired more information, meteorites started to be considered key pieces for understanding the formation of the solar system. A crucial moment in the history of meteorites was the discovery of their extraterrestrial origin. Until the 19th century, many believed they were simply rocks falling from mountains or volcanoes. However, when scientists like the German Ernst Chladni began to study meteorites, they realized that they were fragments of asteroids and other celestial bodies. This revelation changed the perception of the nature of the cosmos and the position of the Earth within it. The influence of meteorites is not limited to science. These objects have also inspired artists throughout the centuries. Painters, writers, and filmmakers have found powerful symbolism in meteorites. In literature, meteorites have been portrayed as harbingers of change, as seen in H.G. Wells' famous science fiction work, The War of the Worlds. This narrative shows us how encounters with the extraterrestrial can challenge our view of humanity and our place in the universe. In the realm of technology, meteorites have left their mark in surprising ways. For example, meteorite steel, known for its quality and strength, has been used in the making of swords and tools throughout history. This special metallurgy has been valued in different cultures, becoming a symbol of power and prestige. As we move into the modern era, meteorites continue to be objects of fascination. Many expeditions have been carried out to find meteorites in different parts of the world, and scientists strive to analyze every fragment they manage to collect. The search for meteorites is not only a scientific adventure, but also a way to connect with the past and better understand the history of the solar system. The scientific community has also realized that meteorites may contain clues about life on other planets. Some theories suggest that these celestial bodies could have brought the necessary ingredients for life to Earth. Imagine the impact it would have on our understanding of the universe if we discovered that life, as we know it, has an extraterrestrial origin. Meteorites have also left a mark on popular culture, from movies to video games. Their representation has evolved over time. They have often been depicted as dangerous and destructive, representing humanity's fear of the unknown. However, they can also be seen as agents of change and transformation, prompting humanity to look to the stars and dream of the future. The story of meteorites is ultimately the story of human curiosity. From ancient to modern times, our relationship with these celestial objects has led us to explore the cosmos and question our existence. Every meteorite that falls to Earth is a reminder that we are connected to the universe in ways we are just beginning to understand. In the future, research on meteorites will only continue to grow as technology advances. So does our ability to study these objects more deeply. Who knows what secrets meteorites still hold that are waiting to be discovered? The exploration of these celestial bodies will not only enrich our scientific knowledge, but will also continue to inspire artists, thinkers, and dreamers around the world. The history of meteorites and their impact on humanity is a testament to our capacity for wonder and exploration of the unknown. Every fragment of rock that falls from the sky invites us to reflect on our place in the vast universe. With each discovery, we come a little closer to understanding not only the origin of meteorites, but also that of our own existence. The search for meteorites is a fascinating journey that combines science, adventure, and a bit of luck. When we look at the sky and see a shooting star, what we are really witnessing is a meteor, a small fragment of material that travels through the Earth's atmosphere. But what happens to those fragments once they reach the ground? How do we know they are meteorites and not just ordinary rocks? This is where the exciting search begins. Scientists have developed a variety of techniques to find meteorites. From careful observation of the night skies to expeditions in deserts and polar regions. Can you imagine being part of a team that travels to Antarctica, where the white of the snow and ice makes dark meteorites stand out like precious jewels? In this inhospitable place, each meteorite found can tell a story of billions of years. One of the most intriguing questions is, how can scientists be sure that what they have found is a meteorite? Certain criteria have been established to help identify these fragments. First, the physical characteristics of the object are examined. A meteorite tends to be denser than an ordinary rock and may have a smooth surface with small fusion marks. Additionally, meteorites are often composed of metals like nickel and iron, which are uncommon in terrestrial rocks. But there is something even more exciting. Scientists use advanced techniques of chemical analysis and spectroscopy to determine the composition of a meteorite. This allows them not only to confirm it as a meteorite, but also to trace its origin in the solar system. Isn't it amazing to think that a small rock can be a messenger from space that brings information about the birth of our solar system? In addition to active searching, there is another way to find meteorites: impacts. When a meteorite strikes the Earth, it leaves behind a crater and often fragments of the original object. This has led to some remarkable discoveries in places like the Arizona desert, where the Barringer crater, also known as the Meteor crater, reveals the history of an impact that occurred nearly 50,000 years ago. But not only desert locations are good for searching. Scientists have also found meteorites in unexpected places, such as the ocean. Can you imagine the number of meteorites that could be resting on the ocean floor, waiting to be discovered? This raises an intriguing question. How many more meteorites could be waiting to be found on Earth? Technology also plays a crucial role in the search for meteorites. With the use of drones and satellites, researchers can conduct aerial surveys to locate areas of interest where meteorites may have fallen. This makes the search more efficient and less reliant on chance. Thus, science is constantly advancing, and each new discovery can change our understanding of the cosmos. International collaboration is another fascinating aspect of the search for meteorites. Researchers from different countries often work together, sharing data and samples. Imagine a group of scientists from around the world gathered in a laboratory, analyzing a meteorite that has traveled millions of kilometers just to reach their hands. It is a perfect example of how science brings together people from diverse cultures in the pursuit of knowledge. However, not everything is easy in the search for meteorites. Scientists face challenges such as extreme weather, lack of resources, and sometimes even bureaucracy. For example, in some countries, obtaining permits to search for meteorites in protected areas can be a complicated process, but perseverance is key, and many researchers are willing to overcome these obstacles for the promise of a discovery. Each meteorite found is a treasure that can offer clues about the past of the solar system, but what happens once one is found? Meteorites are carefully catalogued and studied. Each analysis can provide information about their composition, age, and, in some cases, about the process that led them to become meteorites. This can include data about the early solar system, planet formation, and the evolution of celestial bodies. And here arises another fascinating question. How can meteorites change our view of the universe? As we understand more about their origin and composition, we begin to glimpse how planets formed and ultimately how Earth came to be. Each discovery is another piece in the cosmic puzzle. The search for meteorites has also inspired many people. From enthusiasts to renowned scientists, the desire to find and study meteorites has led to numerous expeditions and discoveries. From the first recorded meteorite in history, which fell in Egypt over 3,000 years ago, to the most recent meteorites found in Antarctica, the history of the search is full of adventures. Finally, it is important to reflect on the relevance of finding meteorites. They not only help us better understand our own planet, but also connect us to the vast cosmos. Each meteorite is a reminder that we are part of a much larger and more mysterious universe, so the next time you look at the sky and see a shooting star, remember that it could be the beginning of an exciting adventure, one that invites you to explore the past of the universe and discover the secrets it still holds. When we look at the night sky, we encounter a vast ocean of stars, planets, and of course, meteorites. But have you ever wondered what happens to these fragments of rock and metal when they venture to other planets? Especially Mars. The science behind meteorites on other worlds is fascinating and can reveal secrets about the history of the solar system. On Mars, meteorites are true space travelers that have crossed billions of kilometers to reach its surface. But how do we know that these meteorites are really of Martian origin? The answer lies in their chemical and mineralogical characteristics. When scientists analyze a meteorite, they look for elements and compounds that are unique to Mars. It's as if each meteorite carries a cosmic passport that tells its story of origin. Martian meteorites, known as shergottites, nakelites, and chassignites, are three main types that have arrived on Earth. Each of them has its own history and composition, as if they were different regions of the same country. Shergottites, for example, are young and formed only a few million years ago, while nakelites are around 140 million years old. This variety allows us to understand how Mars has changed throughout its geological history. An intriguing aspect of Martian meteorites is how they have formed, through processes such as volcanic eruptions or asteroid impacts. These rocks have been expelled from Mars, traveling through space until they finally fall to Earth. Imagine Mars as a huge garden and the meteorites as seeds that, after being launched into the air, can sprout in a distant land. Every time a new meteorite is discovered, a window opens to an ancient and unknown past. The study of meteorites has also allowed scientists to better understand Mars's climate. By examining the chemical components of these meteorites, evidence of water and other elements has been found, suggesting that Mars may have been a wetter place in the past. This raises intriguing questions. What happened to the water on Mars? Could it have harbored life at some point? Each answer leads us to more questions, as if we were unraveling an ancient mystery. One challenge scientists face is identifying Martian meteorites on Earth. Being similar to other meteorites that come from asteroids, it can sometimes be difficult to differentiate them. That's why technology plays a crucial role. Scientists use advanced tools to analyze the isotopic composition of meteorites, as if they were using a microscope to uncover the secrets hidden in each fragment. This technology allows them to trace the history of the meteorites and their journey from Mars to our planet. But what about the search for these meteorites on Mars itself? Space missions, such as the rovers that have explored its surface, also look for meteorites. Like an explorer in a dense jungle, the rovers must navigate obstacles and difficulties to find these hidden treasures. Every meteorite found on Mars not only provides information about the planet, but also helps scientists better understand how our own planet formed. As we advance in our exploration of space, the possibility of finding meteorites on other planets becomes increasingly exciting. Jupiter's moon, Europa, and Saturn's moon, Enceladus, are places where conditions suitable for life may exist. And meteorites could tell stories about these moons that we have yet to imagine. What secrets could meteorites from these distant worlds reveal about the possibility of life in the universe? The search for meteorites is not limited to Mars. Scientists are interested in studying meteorites on other celestial bodies, such as asteroids and comets. These objects are considered time capsules that preserve information about the early days of the solar system. By studying them, researchers can see how planets formed and how our cosmic neighborhood has evolved. Researching meteorites on other planets is also fundamental for space mining. If one day we decide to exploit the resources of other celestial bodies, meteorites could be a valuable source of metals and minerals. Imagine meteorites as a floating treasure chest in space filled with valuable resources waiting to be discovered. Space mining could change the way we interact with space and open new possibilities for humanity. However, exploring meteorites on other planets is not without challenges. The technology needed to collect and analyze meteorites in space is complex and costly. Additionally, missions to explore other worlds take time and require meticulous planning. But each advancement in this area brings us closer to answering questions about our place in the universe. In conclusion, meteorites on other planets, especially on Mars, are carriers of ancient stories that help us understand not only the past of our solar system, but also the fate of Earth. Each fragment that reaches our surface represents a tangible link to other worlds, and research continues to reveal secrets that could change our view of the universe. The fascinating connection between Earth and Mars through meteorites reminds us that we are all interconnected in this vast cosmos, and that each discovery is another step toward understanding our place within it. Have you ever imagined what it would be like to have a space treasure within reach? Space mining at its core is precisely that, the possibility of extracting valuable resources from the meteoroids that traverse our solar system. These ancient travelers of space are not just wandering rocks, they are true time capsules that could contain precious metals and other materials that could be of great use to humanity. But how does that idea of mining translate into reality? First, it is crucial to understand what types of meteoroids we might consider for mining. There are metallic meteoroids, which are rich in iron and nickel, and rocky meteoroids, which can contain valuable minerals like gold, platinum, and other rare metals. Imagine that each of these meteoroids is like a small space mine filled with resources that might be hard to find on Earth. But how do we know which meteoroids are worth it? The answer lies in exploration. Space missions have begun to focus on identifying and classifying these celestial bodies. And what about the costs? This is where science and technology come into play. It is estimated that as our exploration and mining capabilities improve, the costs associated with collecting materials from meteoroids could become competitive with traditional mining industries on Earth. But is it really worth it? The answer could be a resounding yes. Meteoroids can contain metals that are scarce on our planet. For example, platinum, which is essential for various industrial applications, could be obtained from meteoroids at a lower cost. Furthermore, access to these resources could be crucial for future missions to Mars and beyond. Imagine building extraterrestrial bases using materials extracted directly from asteroids. Wouldn't that be amazing? However, space mining is not without its challenges. One of the main obstacles is the technology needed to extract these resources efficiently. Currently, we are in the early stages of developing tools that could assist in this task. What kind of tools are needed, you may ask? From robots that can drill the surface of meteoroids to transportation systems that can bring these materials back to Earth, international collaboration will be key in this process. Just like in the exploration of the oceans or in polar research, efforts to mine in space will require a joint approach from various nations and organizations. How will these initiatives be coordinated? Through agreements and treaties that regulate the extraction and use of space resources, something that is still in development. A fascinating aspect of space mining is the possibility of using in situ resources, which means we could use what we find in space to support future missions. This could reduce our dependence on Earth and facilitate the colonization of other celestial bodies. Can you imagine a future where humanity lives and works on Mars? Using materials extracted from nearby asteroids, the idea is exciting and opens up endless possibilities. For those interested in science and technology, space mining represents a fascinating frontier. Advances in this field could not only help us obtain valuable resources, but also develop new technologies that could benefit humanity as a whole. Who knows? Perhaps what we learn from meteoroids and their exploitation will help us solve some of the most pressing problems we face on Earth today. The search for meteoroids is also driving renewed interest in education and scientific research. Each discovery about these celestial bodies brings us closer to understanding the origin of the solar system and the history of our planet. Thus, space mining is not just about extracting resources, but about unraveling the secrets of the universe. In conclusion, mining meteoroids is not just a fantasy out of a science fiction movie. It is a possible reality that could revolutionize our way of interacting with space. As we advance in this field, it will be fascinating to see how humanity prepares to harness these resources and what impact it will have on our future. The question now is, are we ready to embark on this space adventure and discover what treasures await us in the vast universe? Meteorites have left an indelible mark on the history of our planet. Their arrival on Earth has been a phenomenon that, while often presented as terrifying, has also had fascinating and sometimes positive consequences. One of the most notable events in Earth's history was undoubtedly the impact of a meteorite. But how do we know that these impacts have shaped our planet and its history? Meteorite impacts can be compared to the great storms that batter a ship in the middle of the ocean. Just as a storm can change the course of a journey, meteorites have altered the course of Earth's history. For example, it is believed that a meteorite approximately 10 kilometers in diameter was responsible for the extinction of the dinosaurs. This event, known as the Cretaceous-Paleogene extinction, occurred about 66 million years ago and marked the end of an era. But what really happened in that cataclysm? The collision of this meteorite released energy equivalent to billions of atomic bombs. The impact generated extreme heat, causing massive wildfires and throwing dust and debris into the atmosphere, which blocked sunlight for months. This resulting darkness caused a drastic drop in temperatures and disrupted Earth's ecosystems. However, the extinction of the dinosaurs also opened the door to the evolution of mammals and eventually the emergence of humans. So while the impact was devastating, it was also a catalyst for life as we know it. Meteorite impacts have not only played a role in extinction events. Throughout history, they have also been responsible for the creation of craters, which are like scars on the Earth's surface. One of the largest and most well-known craters is Chicxulub in Mexico. This crater is a tangible reminder of the collision that changed the course of life on our planet. Now, we think about what other craters exist and how they have influenced the geography of Earth. A crater may seem like a simple depression in the ground, but it is a testament to the history of our planet. Each time a meteorite impacts, it leaves a mark that scientists study to understand not only the event itself, but also the conditions of Earth at that time. What do these craters tell us about the past? How have our lands and seas changed? In addition to the large impacts, we must consider the small meteorites that fall daily on our planet. Although not all of them create large craters, they can have significant effects on the environment. For example, some meteorites may contain compounds that, upon entering the atmosphere, create explosions that sound like thunder. This is known as a meteor. And while its impact is less dramatic than that of a large meteorite, its frequency is much greater. The history of meteorite impacts also leads us to reflect on planetary defense. Scientists have developed methods to track potentially hazardous objects that could threaten Earth. It resembles a team of watchmen scanning the horizon for any ship approaching the shore. With modern technology, we can identify and study these objects, assessing their trajectory and the risk they pose. But what happens if we detect a meteorite heading toward us? The possibility of a future impact raises unsettling questions. Are we prepared to face a new extinction event? Fortunately, advances in space technology have allowed us to propose solutions, such as diverting a meteorite. This may sound like something out of a science fiction movie, but scientists are working on real strategies to protect our home. However, it is also important to remember that not all impacts are disastrous. Throughout history, some meteorites have brought valuable materials that have fueled human curiosity and driven scientific research. Meteorites are like messengers from space, bringing with them secrets about the formation of the solar system and the composition of other celestial bodies. Thus, the history of meteorite impacts is a journey that spans from the creation of craters to the evolution of life on Earth. Each impact is like a chapter in a book that narrates the story of our planet. What else will we discover in the future about these fascinating travelers from space? Research continues, and each new finding brings us closer to understanding our place in the universe. In conclusion, meteorites are much more than simple rocks falling from the sky. They are witnesses to cataclysmic events that have shaped Earth and influenced the life we know, from their devastating consequences to their potential to open new avenues of research. Meteorites are a constant reminder that the universe is a place full of surprises and mysteries. The history of our planet is intertwined with the stories of these cosmic travelers, and each new discovery invites us to explore and better understand our world and beyond. Planetary defense is a fascinating topic that connects us with the universe and reminds us that although we live in a relatively safe world, there are cosmic forces that could change our lives in an instant. Did you know that there are thousands of objects in space that, if they deviate from their trajectory, could impact Earth? These are the asteroids and comets that sometimes become meteoroids, but what are we doing to protect ourselves from them? Imagine for a moment that you are enjoying a quiet afternoon gazing at the clear sky. Suddenly, a bright object streaks across the firmament. It may seem like a beautiful spectacle, but that same object could be a threat. Scientists are working hard to identify and classify these objects. In reality, planetary defense resembles an alarm system that alerts us to potential dangers. But how does it work? The first line of defense is telescopes. These powerful instruments are distributed around the world and are tasked with scanning the sky for asteroids. You could think of them as treasure hunters in the vast ocean of space, searching for those small pieces of rock that could become a big problem. But what happens if an asteroid approaches Earth? The answer to this question is not so simple. Scientists not only have to detect an asteroid, but they also need to calculate its trajectory. This is akin to predicting the future. Once they identify one that could be dangerous, a series of calculations and simulations are initiated to determine if there is a risk of impact. If an imminent threat is detected, various strategies come into play. But what are those strategies? One of the most intriguing ideas is to deflect an asteroid. Imagine a huge truck on the road. If someone wants to change its direction, they can push the truck with another vehicle or even use a wedge. Scientists are working on similar technologies for asteroids. They could send a spacecraft to collide with the asteroid and change its course, as if it were a game of cosmic billiards. But is it really possible? There are several missions in development aimed at testing these techniques. One of them is the DART mission, which aims to crash a spacecraft into an asteroid to see if its trajectory can be altered. This leads us to wonder, what would happen if we couldn't deflect an asteroid? The answer is equally intriguing. Scientists are also studying how to mitigate the effects of an impact. This could include evacuating threatened areas or creating shelters. However, the best defense is always prevention. Another crucial aspect of planetary defense is international collaboration. Earth is a shared home, and when it comes to threats from space, cooperation is vital. Imagine if all the countries in the world came together to face a common challenge. This is the philosophy behind various treaties and international agreements that seek to coordinate efforts for monitoring and defending against asteroids. Technological advancements are impressive, and it's astonishing to think about how science fiction is beginning to become reality. But here arises a question: how prepared are we really? Most of us are not aware of the magnitude of the threat posed by meteoroids. Education on this topic is essential, and it's one of the reasons why scientists and educators work to inform the public about planetary defense. As we delve deeper into this topic, we must also consider history. Throughout the centuries, humanity has witnessed cataclysmic events caused by meteoroid impacts. For example, the famous Chicxulub event, which is believed to have contributed to the extinction of the dinosaurs. What lessons can we learn from our past to protect our future? The search for meteoroids and their study not only helps us better understand space, but also prepares us to face future dangers. Each discovery provides valuable information that can be crucial in planetary defense. Therefore, research on meteoroids is not just about scientific curiosity, but about a necessity for survival. In conclusion, planetary defense is a constantly evolving field that combines science, technology, and cooperation among nations. As our knowledge and capabilities grow, so does our responsibility to protect our home. The next time you look up at the sky and see a shooting star, remember that behind every flash, there is a collective effort to ensure that our planet remains safe from the dangers of space. The story of humanity is intertwined with the cosmos, and it is our task to take care of it. Meteorites are not only fascinating objects from space, but they have also played a crucial role in the development of modern technology. Did you know that many advancements in materials and scientific processes have their origins in the study of these celestial bodies? Let's explore how meteorites have influenced the world of technology in ways you might not imagine. For example, in the field of metallurgy, certain meteorites are composed of rare metals that are difficult to find on Earth. Researching these meteorites has allowed scientists to better understand how these metals behave under different conditions, leading to the creation of stronger and lighter alloys. This is similar to how a chef might experiment with different ingredients to create an exquisite dish. In this case, the ingredients are the metals that come from places as distant as outer space. The exploration of meteorites has also contributed to the improvement of detection technologies. Scientists are developing sensors that can detect the composition of a meteorite the moment it enters the atmosphere. This process is like having a space nose that can identify what type of meteorite is approaching. These technologies are not only valuable for science, but also have applications in the security industry and space exploration. Another interesting aspect is imaging technology. When researchers analyze meteorites, they use advanced imaging techniques that allow them to see the internal structure of these bodies. Imagine having a microscope that can reveal hidden secrets. This type of technology has filtered into other fields, such as medicine, where imaging scanners are used to detect diseases in their earliest stages. Thus, what we learn from meteorites does not remain solely in the realm of astronomy, but also helps improve people's health. Moreover, meteorites have been a source of inspiration for creating new materials. Some meteorites contain minerals that are not found on Earth, and their study has led to the creation of innovative materials that are more resistant to high temperatures or have unique properties. This is comparable to how artists seek new pigments for their works. Sometimes the answer lies in the least expected places. The aerospace industry is another field that has seen significant benefits from the study of meteorites. By understanding how meteorites wear down and decompose upon entering the atmosphere, Engineers can design spacecraft that can withstand the harsh conditions of space. Thermal shield technology, for example, has been inspired by the behavior of meteorites during their atmospheric entry. It's as if we are taking advice from meteorites on how to protect ourselves from the dangers of space. Meteorites have also influenced energy. In some studies, certain compounds found in meteorites have been identified as potential bases for new energy sources. This could lead to the creation of more efficient batteries or even new forms of renewable energy. Just as inventors seek new ways to harness natural resources, scientists look to the sky, searching for answers in the ancient history of the universe. Nanotechnology is another field where meteorites have left their mark. By studying the structures at the molecular level in meteorites, researchers have developed new methods for creating nanoscale materials that are stronger and lighter. This is like building a house with tiny bricks that, together, form a more solid structure than traditional ones. The future of construction and technology may lie in the secrets held by these celestial bodies. Artificial intelligence has also benefited from the study of meteorites. Data collected from meteorites is used to train algorithms that help predict the behaviors of celestial bodies. Imagine having an assistant that can foresee patterns and behaviors in the universe. This applies not only to meteorites, but can also assist in areas like meteorology or real-time data analysis. And what about space travel? Research on meteorites has been fundamental in planning missions to other planets. Understanding how meteorites have affected the surface of other worlds helps us prepare for future explorations. Each mission is a step into the unknown, and meteorites serve as maps guiding us on this space journey. It's fascinating to think that although meteorites are objects from space, their impact is felt here on Earth. The technology we use daily, from our smartphones to our computers, may have its roots in the research of these celestial bodies. In a way, meteorites have contributed to the technological revolution we are experiencing. As we advance in our understanding of the universe, we can expect meteorites to continue providing valuable insights and technologies. Each new discovery opens the door to more questions and possibilities. Human curiosity, driven by the study of these fascinating objects, is what will take us even further in our exploration of the cosmos. In the end, the connection between meteorites and technology is a reminder that what seems distant and foreign can indeed have a profound impact on our daily lives. And so, as we look to the sky for answers, we are also creating a brighter future here on Earth. The future of meteorite research is a fascinating topic that sparks curiosity and wonder. With each discovery, we get a little closer to answering fundamental questions about our place in the universe. What secrets do these space travelers still hold? The answer to this question could change our understanding of planet formation and the origin of life itself. Technological advancements have opened new doors in meteorite research. For example, space telescopes and interplanetary probes have allowed scientists to observe and analyze meteorites in more detail than ever before. Imagine being able to observe a rock billions of years old on its journey through space. That is the reality that modern technology has made possible. But how are these advancements used to study meteorites? One of the most exciting methods is asteroid exploration. Missions like the Japanese Hayabusa probe and the American OSIRIS-REx have landed on asteroids, collecting samples and bringing them back to Earth for analysis. These missions are like small expeditions into the past, where each grain of collected material tells a story. What information do these samples reveal about the primitive solar system? Meanwhile, in laboratories, scientists are using advanced techniques to analyze the isotopes of meteorites. This analysis is like piecing together a puzzle where each piece provides clues about the history of these celestial bodies. Isotopes can reveal details about the origin of a meteorite and the conditions under which it formed. What surprises does this research hold for us? As the scientific community advances, new questions also arise. For example, how do meteorites influence the search for life on other planets? The Mars Sample Return mission, which plans to bring samples from Mars to Earth, aims to investigate whether any meteorite could contain signs of past life. The possibility of discovering life on another planet is a dream that has fascinated humanity for centuries. What would that mean for our understanding of the universe? Delving into space mining, meteorites could also become a valuable source of resources. Rare elements and precious metals which are scarce on Earth may be more abundant in some asteroids. This raises the possibility that in the future we could extract materials from these celestial bodies for use in technology and space exploration. Could asteroid mining be the key to a new era of innovation? Furthermore, meteorite research is helping scientists better understand the risks they pose. Planetary defense is a growing field, and each new discovery about the composition and trajectory of meteorites allows us to be better prepared. What measures are being implemented to protect our planet from potential impacts? International collaborations are also playing a crucial role in the future of meteorite research. The exchange of data and resources between countries is accelerating progress in this field. In a world where science knows no borders, the union of efforts can lead to surprising discoveries. What collaborations are underway, and what could they mean for the future of space exploration? On the other hand, popular culture has influenced the way we perceive meteorites. Movies, books, and video games have fueled our imagination about space and its mysteries. This has led to an increase in public interest in astronomy and meteorite research, which in turn fosters investment and support for new missions. How does culture influence science? It is essential to remember that every meteorite that falls to Earth is a learning opportunity. Each one has a story to tell. And as we advance in research, we are unraveling the secrets of our solar system. How many more stories do we have left to discover? Looking to the future, meteorite research will not only help us understand our past, but will also shape our destiny. As we explore, collect, and analyze, each discovery brings us closer to answering questions that have persisted for generations. Where will this insatiable curiosity take us? In conclusion, the future of meteorite research is bright and full of possibilities. With each technological advancement and each new mission, we are unraveling the mysteries of the universe. The search for meteorites is not just a scientific adventure, but an exploration that connects us with the cosmos and reminds us how small we are in the vast stage of space. As we continue to investigate and learn, the sky will not be the limit, but just the beginning. What is the difference between a meteorite, a meteor, and a meteoroid? This is a question many people ask, and the answer is more interesting than it seems. To start, a meteoroid is a small fragment of rock or metal floating in space. Think of them as the tiny crumbs of a cookie that have fallen while you enjoy it. The cookie in this case is an asteroid or a comet. When a meteoroid enters the Earth's atmosphere and begins to burn due to friction with the air, it becomes a meteor. It would be like those crumbs igniting as they hit the ground, leaving a bright trail behind. Finally, if a meteor survives the journey through the atmosphere and lands on Earth, we call it a meteorite. So in summary, a meteoroid is the one floating in space, a meteor is the one shining as it enters the atmosphere, and a meteorite is the one that reaches the ground. Did you know that meteorites can be older than the Earth itself? This may sound surprising, but many meteorites formed at a time before our planet, making them time capsules of the solar system. By studying these meteorites, scientists can gain clues about what the solar system was like in its early days. It's like finding a history book in an ancient library that tells stories from a distant time. One of the questions that often arises is, why are meteorites important for understanding life on Earth? The answer lies in the hypothesis that some meteorites may have brought the necessary ingredients for life. Imagine that space is like the pantry of the universe, filled with ingredients that, when combined in the right way, can lead to something wonderful, like life. Meteorites could be those surprise packages containing the essentials for life to flourish, such as water and organic compounds. Speaking of water, another great mystery is the relationship between meteorites and the presence of water on our planet. Some studies suggest that water-rich meteorites crashed into primitive Earth, depositing that precious liquid that is fundamental for life. It's as if the water from meteorites was the first rain that soaked the Earth, creating a favorable environment for the emergence of life. Why are some meteorites more valuable than others? This is due to their composition and age. Some meteorites, like those from the Moon or Mars, are extremely rare and offer invaluable information about the history of these celestial bodies. It would be like finding an ancient coin that once belonged to a king. The value is not only in the material, but in the history it carries. An intriguing question is, how do scientists find and study meteorites? The techniques are varied and range from observing night skies where meteors can be seen, to searching in deserts and polar regions where meteorites may be easier to find. This is similar to a treasure hunt, where scientists are like modern explorers, armed with tools and technology to discover these treasures from space. Space mining is another fascinating topic related to meteorites. Some experts believe that in the future we could extract valuable resources from meteorites to use in space missions or even on Earth. Imagine that meteorites are like drawers filled with rare materials that we could use to build spacecraft, batteries, or even new types of technology. What about the impacts of meteorites on the history of our planet? Earth has been struck by meteorites throughout its history, and some of these events have had dramatic consequences. For example, the impact believed to have led to the extinction of the dinosaurs is a reminder that meteorites not only bring wonders but also challenges. It's as if the universe is throwing a reminder that we must always be alert to the unexpected. Planetary defense is a topic we cannot overlook as we learn more about meteorites and their trajectories. Scientists are working hard to identify and mitigate the risk of impacts. This is similar to having an evacuation plan in case of a storm. It's about preparing and protecting ourselves from what may come. International collaboration in this field is essential, like a team of firefighters coming together to combat a large fire. Finally, another question arises: what future awaits meteorite studies? With new space missions on the horizon and advances in technology, meteorite research promises to unveil still unknown secrets about the origin of the solar system and life on Earth. It's as if we are about to open a new chapter in a book that we have not yet begun to read. Questions about meteorites are as fascinating as the meteorites themselves. Each answer leads us to new inquiries and explorations, reminding us that the universe still holds many secrets to discover. Each meteorite tells a unique story, and by studying them, we not only learn about the past, but also open the door to a future full of possibilities. So the next time you see a meteor streaking across the sky, remember that it is not just a flash of light, but a reminder of the wonders of the universe and the secrets that, through meteorites, we can still uncover. The journey of knowledge is just beginning, and every question that arises is another step toward understanding our place in the cosmos. As we look at the starry sky, we encounter a vast universe full of mysteries and wonders. Throughout this video, we have explored in depth the fascinating history of meteorites and their crucial role in the formation of our solar system. But why is it so important to understand these celestial bodies? What secrets do they reveal about the origin of Earth and ultimately about ourselves? Meteorites are like ancient books that have traveled through time and space, carrying stories from the past. Each fragment that falls to our planet is a testament to the creation of the solar system and the processes that gave life to Earth. By studying them, scientists can decipher the chapters of our cosmic history, from the birth of planets to the arrival of the ingredients that made life possible. Some may wonder, do meteorites really have anything to do with the water we know on Earth? The answer is a stunning yes. These celestial bodies have been fundamental in delivering water to our planet. By understanding their composition and origin, we are one step closer to unraveling the mystery of how life emerged. Let's imagine meteorites as messengers bringing vitality and essential elements from distant corners of space. Throughout history, we have learned that not all meteorites are the same. There are different types, each with its own story to tell. From rocky meteorites to metallic ones, each offers us a unique insight into the formation of our solar system. But how do we know which meteorites are the oldest? Some of them have been traveling through the cosmos for billions of years, and by analyzing them, scientists can reveal secrets that date back to the very beginning of our solar system. The connection between meteorites and life doesn't end there. Some propose the hypothesis that some of these fragments may have brought with them the necessary components for the origin of life on Earth. Is it possible that in their journey through space, these meteorites sowed the seeds of life on our planet? This idea, which might seem straight out of a science fiction movie, becomes a fascinating possibility when considering the chemical properties of certain meteorites. Meteorite impacts on Earth have left marks on our history, both physical and cultural. From ancient legends to modern scientific discoveries, these events have taught us about the fragility of our planet and the vastness of the universe. But how can we protect ourselves from future impacts? Scientists are working hard on planetary defense, seeking ways to identify and mitigate the risks posed by these celestial bodies. Research on meteorites is not only crucial for understanding our past and present, but also opens up a world of possibilities for the future. Could meteorites be the key to space mining? With the growing exploration of space, these bodies are being considered as sources of valuable resources. Imagine a future where the elements needed to build structures on other planets come from meteorites. This idea could radically change our way of exploring space. As we bid farewell to this journey through the universe of meteorites, it is essential to reflect on what we have learned. These fragments of the cosmos are not just remnants of ancient asteroids. They are carriers of vital information that help us understand our existence and the environment around us. They connect us to the past and inspire us to continue exploring the future. The importance of meteorites extends beyond science. It intertwines with our culture, our history, and our quest for knowledge. As we look up at the sky, let us remember that each star and every meteorite that streaks across the night has a story to tell. A story that reminds us that we are part of a vast and beautiful universe. So what does the future hold in our quest for meteorites? As technology advances and our space missions become more ambitious, we will continue to discover more about these fascinating objects and their relationship with life, water, and the origin of the solar system. Each discovery brings us a little closer to understanding not only our planet but also our place in the cosmos. In conclusion, meteorites are much more than rocks falling from the sky. They are a window to the past, a bridge to the future, and a source of inspiration for humanity. The next time you see a meteor streaking across the night sky, remember that you are not just witnessing a natural phenomenon, you are connected to a story that goes back billions of years. That is the essence of meteorites and their importance in our understanding of the universe.